finished in the last session on Rolle's theorem, and we did some simple application of Rolle's theorem by remembering the fact that a function fx must be continuous in the closed interval AB. This closed interval, it is continuous. Fx must be differentiable in the open interval AB, and at the extreme points of the interval the functional values will be the same, that is fa equal to fb. Ordinates are same at those 2 points. Then it explains there will be a horizontal chord of the curve. That horizontal chord will be ensured by this one, that fa equal to fb. If we plot the graph of a function, any function which has a horizontal chord, then Rolle's theorem ensures that there exists at least one point where tangent is going to be parallel to the x-axis. So if these are 2 points, then the interval we are taking as AB, this point has x coordinate a comma 0, this one b comma 0, then there exists at least one horizontal tangent between these 2 points. In this graph you can see that there are 3 points where tangent will be parallel to x-axis. So there exists a point, at least one point C between A and B, such that f dash C equal to 0. But you must remember that this, we find this value of x, which is C, we find after verifying all these things. If it is continuous, if it is differentiable and extreme points functional values are equal, then only we can find the point C which lies between A and B, where if that C is going to be equal to 0. Now, Rolle's theorem may not be applicable if these 3 conditions, one of these 3 conditions not valid. In the following examples, we will see that the Rolle's theorem may not be valid when one of the conditions given here is violated. Let us see the question number 1, part 1, where fx we have taken mod x, and we are supposed to check in this closed interval -1 to 1. If we go by plotting the graph of the function, then we will see that the graph of the function has a kink at the point x equal to 0. It proves the existence of 2 tangents at this point. The tangent, one has slope equal to 1 because this angle will be 45 degree, this is y equal to x and this is y equal to minus x. So at the point 2 tangents exist means dy by dx has 2 values. 2 values means function will not be differentiable at x equal to 0, which is a point in between -1 and +1. So the function is not differentiable at the point x equal to 0. The differentiability condition you can check by using the existence of derivative also, that if we rewrite the function fx equal to x for x greater than or equal to 0, minus x for x less than 0, and if we calculate derivative at x equal to 0, that is left hand derivative at x equal to 0, then this is going to be limit h tending to 0, fh minus f0 by h tending to 0 minus means this point, so it will be limit h tending to 0 minus h minus 0 by h. So value is minus 1. If the value is minus 1 here, and then we calculate the right hand derivative at x equal to 0, we will find r f dash 0 in this form, limit h tending to 0 plus fh minus f0 by h. This will be changed to limit h tending to 0. What is the value of fh here? This will be h minus 0 by h. So the value is 1. So you can see that left hand derivative not equal to right hand derivative. So the function is not differentiable at x equal to 0. Graphically we have seen that. Here analytically also we have proved that they are not equal. You can do it by analytical method. Analytical method is required for many sums when you will not be able to plot the graph of the function so easily. Okay. So by both the method we can say that function is not differentiable at x equal to 0. So Rolle's theorem is not applicable for the first one. I mean fx equal to mod x in minus 1 to 1. 0 is a point here, so it will not be differentiable there. Let us see the function fx equal to sine 1 by x. Is it differentiable there? The interval given here for sine 1 by x, no interval stated. But if we take one interval like previous one, minus 2 to 2 or minus 1 to 1, then we will say that fx equal to sine 1 by x, this function is again not differentiable at x equal to 0. Why is not differentiable? If suppose they have asked you to check it at minus 1 to 1 in this interval. Let us check why it is not applicable over there. At x equal to 0 again we suspect it is not differentiable. So if f dash 0 out of this we will find L f dash 0 first. L f dash 0 means the left hand limit h tending to 0 minus fh minus f0 by h. But another thing I would like to say, here the function not stated clearly for minus x or plus x, so it will be enough to find just f dash 0. If you find f dash 0, it is going to be limit h tending to 0, don't say minus or plus, we just find derivative at x equal to 0. This is going to be sine 1 by h f0. What is the value of f0? That is also not stated. This divided by h. f0 is going to be sine 1 by 0. It will make the function oscillatory. Sine 1 by 0 don't have a fixed value over there. So it will oscillate between minus 1 and plus 1. In this regard, you can say that the function is not even continuous at x equal to 0. And differentiability checking we are doing here, it is not differentiable also there. So the function sine 1 by x, neither continuous nor differentiable at x equal to 0. So Rolle's theorem does not apply for this function in the interval minus 1 to 1. Now let us see another one, fx equal to x to the power 1/3 in minus 1 to 1. What will happen for this function? Fx equal to x to the power 1/3 in minus 1 to 1. Is Rolle's theorem applicable over there? Let us check. For this function again, I suspect even this one for your all entrance examinations, you can do derivative here. You can find derivative f dash x 1 third x to the power 1 third minus 1. This is 1 by 3. This will go down to make the index positive. So this will be x to the power 2 by 3. What is the value of f dash 0 here? F dash 0 is something going to be 3 0 to the power 2 third. This does not exist. Okay, so Rolle's theorem is not applicable for this function due to the same reason the function is not differentiable at x equal to 0. Although it was continuous at x equal to 0, this is defined, but it is not differentiable at x equal to 0. Now let us take the next one, that is fx equal to e to the power x sin x plus cos x. I am taking, suppose the interval I am taking pi by 4 to 5 pi by 4. When you are going to check applicability of Rolle's theorem, you need to remember basic properties of a continuous function. I mean, if there are two continuous functions, their product is continuous, their sum is continuous, division is also continuous, provided the denominator is not equal to 0. So what about e to the power x sin x plus cos x in this interval? Can you check the continuity and differentiability? You never go to check continuity or differentiability. You check only when you are confused. If you are not able to detect whether really it is continuous, differentiable at that point or not. Otherwise, you remember the property of continuous function. By that property, sin x and cos x both are continuous, so their sum is continuous. E to the power x also continuous function. So a continuous function multiplied by another continuous function, their product is also continuous. So this function, if you go by Rolle's theorem statement, fx is continuous anywhere. Obviously it is continuous in pi by 4 to 5 pi by 4. Now, is it differentiable also? Of course differentiable, because sin x, cos x, e to the power x, all are differentiable everywhere. So fx is differentiable in pi by 4 to 5 pi by 4, the open interval. But there is a problem. The third condition, I am guessing although these two conditions satisfied, third condition may not be satisfied. Third condition of Rolle's theorem means f pi by 4 must be equal to f5 pi by 4. Is it satisfied? Let us check for part 3. We find f of pi by 4. This is going to be e to the power pi by 4 sin pi by 4 plus cos pi by 4. So this is going to be e to the power pi by 4. Both the values you all know. 1 by root 2 plus 1 by root 2. So this will be equal to root 2 into e to the power pi by 4. Okay. The value of the function at x equal to pi by 4 is root 2 e to the power pi by 4. Let's see what is its value at the other extreme point, at 5 pi by 4. At 5 pi by 4, it is e to the power 5 pi by 4 sin 5 pi by 4 plus cos 5 pi by 4. What is the value of sin 5 pi by 4? It is e to the power 5 pi by 4. You keep it the same manner. You don't change it. 5 pi by 4 is 5 plus pi by 4. So its value is minus 1 by root 2. This one also value minus 1 by root 2. So this is going to be minus root 2 into e to the power 5 pi by 4. Obviously there is a difference between these two values. At x equal to pi by 4, the functional value was root 2 e to the power pi by 4. Here it is minus root 2 e to the power 5 pi by 4. There is no way to prove that these two extreme values are equal. So here Rolle's theorem is not applicable to the third condition, that the functional values at the extreme points are not equal. So Rolle's theorem does not apply. Now let us take another example where we will find Rolle's theorem applicable or not. The function is stated this manner. fx equal to x minus a to the power m into x minus b to the power n, where mn are positive integers. And a and b both are real, and also it is given, say, a less than b. All these are given. We have to check whether Rolle's theorem is applicable for this function or not. You remember, all of you, I guess all of you remember the properties of continuous function. This function is continuous everywhere. Why? Because if you expand and then multiply together, you will be getting a polynomial function, as mn are positive integers. And you know polynomial functions are continuous and differentiable everywhere. So you don't have to think about the first 2 points. It is continuous and differentiable. And when you are going to answer MCQ questions, you need not check continuity differentiability. Just remember properties and apply it over there. So we have mentally verified the function is continuous and differentiable. In the interval, suppose the interval we are taking, that interval I did not specify. In the interval AB, they have asked you to check. You will say that the function continuous in this interval. You will remember that it is differentiable in the open interval AB. And what is FA here? A minus A, it is going to be 0. What is the value of FB? That is also going to be 0. So FA equal to FB, because they are both equal to 0. So by Rolle's theorem, there exists C in the interval AB such that f dash C is equal to 0. That f dash C we can find by differentiating this function and then putting x equal to C over there. Let us check. Derivative of this will, that f dash x, it will be m x minus a to the power m minus 1 into n x minus b to the power n minus 1. No, the first one it will be x minus a to the power n into x minus b to the power, that m derivative, that first one derivative into second one n, this plus x minus a to the power m n x minus b to the power n minus 1. Okay. Now we can take x minus a to the power m minus 1 common. We can also take x minus b to the power n minus 1 common. So this is going to be changed to m into x minus b plus n into x minus a. Now if we put f dash c equal to 0, at x equal to c, if we put f dash c going to be this thing, that c minus a, when compared to the right side it will be 0, c minus a to the power m minus 1, that c minus b to the power n minus 1, and m into c minus b plus n into c minus a. Okay. Now 0 by this whole thing, that c is not equal to the extreme values, so this is not equal to 0, this is also not equal to 0. So you just transfer it on the right side, that 0 by something, that will be 0. So m plus n into c is going to be equal to only this factor we compare with 0, mb plus na. Alright. Now if we get the value of c from here, this is going to be c is equal to mb plus na. This is mb plus na, that divided by m plus n. You put it there, that is mb plus na, this divided by m plus n. Now question arises, is this one, that mb plus na by m plus n lies in between a and b or not? When I stated the interval is a comma b, this is something like 2 points on x-axis. This point has coordinate a comma 0 and this point has coordinate b comma 0. Now by ratio formula, that section formula, if it is m and this portion is n, in which suppose this segment, this point p divide the segment joining a and b in the ratio m is to n, then p has the coordinate mb plus na, that divided by m plus n. Okay, so everyone can say that the value of c will lie in between a and b, because c is obeying this section formula, c equal to mb plus na by m plus n. Alright. Now let us solve a problem which came in IIT JEE long back, that IIT JEE 2004 question. If fx equal to x to the power a log x and f0 equal to 0, then the value of, this is alpha, value of alpha for which Rolle's theorem can be applied to 0, 1. That alpha will be -2 or -1 or 0 or 1 and 2. Just before you solve this MCQ, little bit insight is required. Can alpha be negative ever? The first two possibilities we can remove in the beginning. It can never be negative. Why? Because that fx, when it is a negative quantity, then that alpha is going to be negative quantity, then x to the power alpha log x is nothing but, suppose alpha negative quantity means alpha equal to minus m. So this will be log x by x to the power m. Alright. We are suspicious about the point x equal to 0, f0 also they have stated. Now the question arises, can we find f0? Can we find the limit before 0 or after 0, just before 0 or just after 0? No. Because if you put x equal to 0 here, the form is not 0 by 0. Log 0 is minus infinity and this is 0. Minus infinity by 0 is not indeterminate form where you can apply L'Hopital rule. So that at the point x equal to 0, the function will not be differentiable if alpha is minus m. So this doesn't exist. Limit x tending to 0, that fx does not exist here. So we can exclude these 2 points in the beginning. -2 and -1 cannot be there. Now there are 2 options. At x equal to 0, what will happen? This we have taken when alpha is a negative quantity. When alpha equal to 0, case by case we are studying. This was when alpha less than 0, now alpha equal to 0. Then fx going to be what? Log x. Fx equal to log x itself also neither continuous nor differentiable at x equal to 0. If you go by the graph of log x function, it's like this. At x equal to 0, it has value which is infinite, minus infinity. So this function is not continuous at x equal to 0. So at the end point f0 we are unable to find, although log 1 equal to 0. So Rolle's theorem cannot be applied for this also. So only one option is remaining out of 4. You will say that it is x equal to half, alpha equal to half. But you can check this also. Why for alpha equal to half? This function, for this function Rolle's theorem is applied. Let us check. Fx is when alpha equal to half. Fx is x to the power half log x. Question is, can we express it in indeterminate form where L'Hopital rule can be used so that you can check continuity differentiability at x equal to 0? Yes, let us try. This you rewrite as log x divided by 1 by x to the power half. Okay. So when we calculate limit x tending to 0 fx, this thing going to be equal to limit x tending to 0 log x by x 1 by x to the power half. This form is obviously infinity by infinity. So we can use L'Hopital rule. So this is going to be changed to limit x tending to 0 1 by x, and this one x to the power minus half. So minus half x to the power minus 3 by 2. So this is changed to limit x tending to 0 minus 2 into x to the power 3 by 2 by x, that is x to the power half. Now this minus 2 is a constant, and when x tending to 0 plus, that we are checking at that point, no, because the interval given 0 to 1. So we check right continuity over there, x tending to 0 plus, this will give us 0 to the power half is 0, so value is equal to 0. So for this function also, it is continuous and differentiable and Bool's theorem applicable when it occurs alpha equal to 1 by 2. Alright.